Okay, so we saw this adjacency model example, and now it's time to write some code. I will be using Postgres with dbeaver. dbeaver is one of my favorite tools. If you use databases a lot, you should use dbeaver, I think. It's really nice, and it's also free and open source. So I'm gonna create a table called categories. We have an ID, which is an auto-incremented field. That will be the primary key. We have a title, should be unique. We have a tree ID, which, because in these categories table, we will store a bunch of trees. All of them starts with a root, then end up with a bunch of leaves. And the only way to distinguish between these trees is by the tree ID. So all of the nodes that is related to one tree will share the same tree ID and so on. Then we have a parent ID, which is a foreign key that references the same table, and on delete and update we cascade. So it's pretty simple. Now we created the table. Then I will insert the first node. And if you remember, the first node will have a parent ID of null. So let's do that. So default is null for the parent ID, so I can just do this. And this function here will generate an ID, which is the tree ID. If you are using any programming language, you can just generate any ID and throw it here. But I'm just gonna do everything with SQL. So now we have this ID. We go to our tables, we can view it. This is the root node for this tree. I'm gonna now store a bunch of nodes. Let me copy paste some code. So first thing, I have these two nodes. I can just store them. Then if I go back here, we have this apple category. I will go and store 3 children for it. And I'll do this. Now that's nice. Our tree looks, say we have this fruits node, fruit node. Then it points, then under it we have apple and mango. Under apple we have the green apple, yellow apple, and a red apple. So that's for inserts, pretty straightforward. But maybe one thing to notice that we had to run a bunch of queries. Maybe if you're doing some kind of migrations or if you need, or if you're writing an unbelievable amount of inserts, maybe like you can maybe remove the foreign key and just write one single insert. It's up to you, but that's one idea you can do. So that's nice. Now for the deletion, we have this rule on the foreign key of cascading in case of a delete. So if I go delete this node, which is with ID 2, now everything that reference that will be also deleted. So all of these 3 will be deleted. If I deleted the root, these 2 will be deleted, and because these 2 got deleted, everything that reference them will also be deleted. This has the ID of 2, and all of these nodes also reference that, so they will be deleted. So deleting the root will delete the whole tree. Let's do that. Now if I go back, refresh, the whole tree is gone. So that's one way to delete, is to cascade. I'm gonna show you a different way where we select one child and uplift it, which requires to run a bunch of queries. Now the first thing to do is when we create the table, we need to remove the cascade rule. So it will only be like this. Now let's run it. Nice. Let's go insert the first root, or the root we have. We'll copy the ID and insert it here. We're gonna recreate the same tree, and let's go check it. Boom, done. Now if you, so okay, now what we need to do is, let's say for example, I'm gonna delete this root, this node which has the ID of 2, and this one has 3 children or 3 nodes attached to it, which is green apple, yellow apple, and red apple. So we need to select one of them. So the queries goes like this. First thing, you need to select all of the nodes that has the parent ID of 2, which is the node we were going to delete. So we got them. Now we need to select one of them to be the new parent. Let's say this one, the green apple. So we have the ID for now in memory. This is how your code should behave. I'm just writing you the end result of the SQL queries. Now we go say update set parent. Update categories set parent ID equal 4, where parent ID equal to 2. So 2 is the node we're gonna delete, 4 is the new parent, which we selected based on the previous result. So let's go run that. Nice. Now if we go check our graph, this one is now not deleted yet, but all of these are referencing green apple, and this node is referencing itself. Of course, we need to fix this. So what we need to do now to fix that, update categories, set parent ID equal to 1, where ID equal 4. This says go to that node that we made the new parent, we uplifted that, and make its new parent ID equal to the node's parent ID that we are gonna delete, which is this one. So all of these information will be in memory. Hey, we are about to delete this one and uplift this one in to replace it. So the parent ID of the old node should be inserted into the parent ID to the new node that will replace that. So that's gonna fix it. Now refresh. Why is this like this? But okay, now it's ordered correctly. So that's now pointing to the root. Now let's go delete the final node we have, which is the node let's delete the node that we wanted to delete. Delete categories, or delete from categories, your ID equal to, now that should have done it. So this is the root. Now we have two children, which is mango and green apple. And green apple also has two children. This means we uplifted green apple instead of apple. Perfect. Now for updates is super easy. It's just one pointer. You have to point into another thing. So let's say this yellow apple should now be a direct child to the root. You just go say update categories, set parent ID equal to 1, which is the root in this case, where ID equal 5, and this will end up looking like this, and that's it. So updates is really simple. It should look something like this, and that's it for updates and deletes and inserts. It's pretty straightforward. Now we will look at traversing this tree and getting information from it. That's it. Bye.